Hey guys, and welcome back to the final part of the neural network controller project. So in this video, we are actually gonna be creating the game and actually the interface that will be used to control the game. So let's get started. So first of all, I'm just gonna import the necessary libraries. In this case, we are simply gonna be needing Pygame, and I think we are also gonna need math. So now let's just initialize pygame over here. So I'll just say pygame.init and we can create the display. To do that, we just say screen is equals to pygame.display.set underscore mode, and we pass in the parameters, which is the width and the height of the screen. Now we will just define them as the game variables over here. So we want the width of the screen to be 600, actually 800, and we want the height to be 600. And now we will set the caption of the screen. So we can just say pygame.display.set underscore caption chrome dinosaur. So now we can code out the main game loop. To do that, we just say running is equals to true. While the game is running, we want to check for events. For event in pygame.event.get, if the event.type is equals to pygame.quit, we will set running to false. And we also want to update the display by saying pygame.display.update. And we also need to fill the screen, so I want to fill it with a white color. So 255, 255, 255, and I'll just say fill the display. So I'll just say screen not fill white, and that's all we need to set up a basic pygame window. So now let me just run this file and actually show you the result. cd desktop /python cd2 neural network controller, and let's just go python3 main.py, and let's see, we will just get a simple white colored blank window. As you can see, that's exactly what we wanted. So now I'm just gonna open up Google Chrome, because we actually need to get some icons for our game. So let's just open up Google Chrome real quick. Alright, so we are gonna be looking at some really basic icons. So I'll just search out flat icon. That's usually where I get all of my images from, since you can download them in 64 by 64 format and you don't need to resize them. So over here I'm just simply gonna search for dinosaur, and we should get a few images showing up. I think this one is pretty good, so I'm just gonna use this one. I'm gonna download it in the 64 pixel format. So let's just download it real quick. Why isn't this downloading? Alright, there we go. So as you can see, we have downloaded tyrannosaurus.png. Now we need to search for a tree, since the Tyrannosaurus will be avoiding trees. So let's just get ourselves a pretty cool little tree image. I think this one is pretty good. I'm just gonna download it in the 64 pixel format. You can down now 64 pixels is recommended, although you can go 32 or 128. So let's just show it up in Finder and drag and drop it into our project so we can actually use it. So now it's taking a second or two to actually download this icon for some reason. But let me just take this one and drag and drop it into my neural network controller file. So let's just put it in there and let's just drag and drop it into assets. So that's usually a good practice if you drag and drop it into a folder called assets. That allows you to make your directory structure look kind of good and it doesn't look very messy. So yeah, so now that we have done that, we can simply close all of this. Now we have all of the necessary things needed to actually proceed. So now let's just work on creating the player class. So creating the player class, I'll just say class player, define underscore underscore init underscore underscore self x y y underscore change. I'll just say self dot x equals x, self dot y equals y, self dot x underscore change y underscore change is equals to y underscore change, and then we will define another method called draw, which will take in two parameters, self and the surface. So first we want to load in the image, so we just load in the image with pygame.image.load, and the image that we want to load in will be assets slash tyrannosaurus.png, tyrannosaurus.png, and then we just want to say surface.blit the image at self.x and self.y coordinates. Now we want to make the player object, so creating the player object, so we just say player equals to player, and we want to spawn him at 100 and height minus 150. So now we actually need to draw our player. So to draw the player, all we do is we just say player.draw on the screen, and that's all you need to do. And so now let's just run our program. Okay, I didn't want to open up Google Chrome, I just executed the previous line of code. Let me run python3 main.py, and if everything is correct, we should get something showing up. All right, y underscore change. All right, so we need to provide him that. So currently let's just keep it at 0. Later on we will give it an actual value. So there we go. As you can see, we have our player showing up over here, which is exactly what we wanted. So now we will actually give it a y underscore change value. Right now I'm just gonna set it equal to 1.3. We will need to play around with it. Currently I'm just hard coding it in. And I will also add in one more statement. I'll just say player.y plus equals player.y underscore change. So now if we run this, as you can see, the player will fall down, which is exactly what we wanted. And I noticed that the player speed is incredibly less, so I will just increase that y underscore change, and now I think it's perfect. But you know what, I'm just gonna keep it 2.5, just keep it a bit fast. And I will also add one more thing over here. So we need to add boundary checking. So we just say that if the player.y is greater than or equal to height minus 150, you wanna set the player.y to height minus 150. So now we will just run this again. and the player doesn't move. And now if I just change this 150 to 350, you will see that the player falls down and then stops falling down at height minus 150. There we go. So that's exactly what we wanted to see. And there we go. So now we have the player basic player movements in place. And since we have set up a player.y, we also need to do one more thing. You won't see it now, but you will see this thing later on. So if the player.y is alright, greater than or equal to the height minus 3, actually, okay, 150 plus 70. So 150 plus 70 is equals to 220. So that means that if the tree is blitted at 150, which is in the same x-axis as the player, then the tree will go up to approximately 220. So that means more specifically 214. So that means we need to keep a little bit of a breathing space between the tree and the player. So if our collisions are a bit messed up, the game is a bit more forgiving. So to do that, I'm just gonna keep it a height minus 300, and then I'll just build the player y to. Then what I wanna do is I wanna set the player y. Okay, now this is a bit of a thing. All right, what do I want to do? Actually, yeah, that's is exactly. We just want to set the player y change to 2.5. Now, I know what you might say. Why are we setting it to 2.5? The reason being, when the player will actually jump, we will make this value negative. And when the player hits this point, we want to make this value positive. So that's why we are writing this line of code. Now, we could actually add some jumping mechanics. But you know what? I'm not in the mood for doing all of that because that does involve a bit of math and stuff. And for a game as simple as this, I don't, it might get a bit overkill to do that. So that's why. So now we can actually create the tree class. So let's do that. So I'll just say class tree. Actually, let me just leave one line over here, and I'll just say define underscore init underscore add a few parameters that are required, x, y, and x underscore change. For the trees, it won't be y underscore change, it will actually be x underscore change. And let me just initialize all of these values over here. So self dot x underscore change is equals to x underscore change, and let's add the draw method. And you know what, I'm just gonna copy the draw method from here. I should have used inheritance, but I always forget to do that. And now I'm just gonna do this tree.png, and now we have created a tree. So now we are also gonna need one more module. I didn't realize we would need this, but we are going to. So now what I will do is I'll make a comment creating the tree objects. So I'll just say tree underscore 1 is equals to tree, and the x coordinate of the tree will be a random value. So let's just try saying random.random from the what do you say, it will be from the width to a width plus 150. The y coordinate will be equal to the same thing, which is a height minus 150, and the x underscore change will actually be a negative value. So I'm just gonna keep it -2 for now. You can keep whatever you want, it's up to you. So now we actually need to draw the tree. So let's actually do that now. So I'll just say tree1.draw on the screen, and you also want to move the tree. So let's just do that. So we just say tree.x plus equals tree.x underscore change. So now let's just run this file again. Oops, there we go. And hopefully we will see a tree that is moving. Tree is not defined. Oops, okay. That's supposed to be tree 1, and that is supposed to be tree 1. So now let's just run this file and hope that it works. There we go. As you can see, we have a tree that's moving, and that's exactly what we want. But right now there's one issue. The tree will disappear and it will never come back, which is something that we don't want. So now we need to add boundary checking for the tree. So we just say that if 3 underscore 1 dot x is less than or equal to, actually less than minus 100, then we want to set the 3 underscore 1 dot x equal to this thing. There we go. So let's run this file again and hope that it works. Alright, as you can see, we have a tree coming in and it should come back again. There we go. That's exactly what we want. So now that we have this in place, we need to first look at the movements. So now let's actually work on movements. This is the cool part. So the way we made the interface, which is right here, is we opened a file called the prediction file. We wrote some things, and then we just closed it. And over here, we don't want to write anything since it's gonna be pointless. Instead of what we wanna do is we wanna read what's written in the prediction file. Here it's written normal 226. Right now I'm just gonna get rid of it. So yeah. So how do we do that? Well, it's actually pretty simple. Alright, so I think I'm just gonna do it in a function. So the code looks a bit neat. So loading in the prediction file, I'll just say define load prediction. I'll just say you know what, I'm gonna be a bit descriptive. Load interface prediction file. And how do you want to do this? So we are going to be using most of the code that we wrote over here, exactly this one, and I'm just gonna pass it over here. Just do that and do that. And we obviously don't want to load it in as a W. We want to load it in as an R. So we'll just say R. So that means that we want to load it in the read thing. So I'll just say prediction file.read, and we want to read the entire thing, and then we simply want to close it. So I think I'm going to save it in a variable called data is equals to prediction file.read, and I just want to print out data. Oops, data. And for now I'm just gonna add some stuff to the prediction file, and now let's just run this function in the while loop. So I'm just gonna do this, and hopefully we should get the data showing up on the screen if everything is working correctly. Otherwise, there we go, and that's exactly what we wanted. Cool. So now we have this data showing up, which is exactly what we wanted, and we basically have our entire game in place. So now that we have a data, actually I don't want to call it data. I just call it data for testing purposes. I want to call it prediction. Actually, model prediction. So we want to check a few things over here. So I'll just say if the model underscore prediction is equals to, now what were the possible things that the model could predict, a jump or a normal? So if that's equals to a jump, I want to, now I could either return jump or I could return like a true. Now since we have like a binary classification thing, I could return true or return a false. And you know what, for now, since we are doing binary classifications, I think I am just gonna return, actually yeah, that's exactly the thing. Right over here, if the model prediction is equals to jump, only then I'm gonna return true, because otherwise we don't really want the uh, player to do anything, because if it's normal, that means that I don't want to jump. So instead of saying return jump, we can just say return true and return false over here. So that's pretty cool, right? So now we have this in place. Now that we have this in place, I'm just gonna run this file right now and see if I haven't broken anything. Now I think it will throw me an error if nothing is present in the file, but apparently it doesn't. That's pretty cool. So now that we have this in place, we are currently returning true, but we actually don't want to return true, right? We actually wanted to do something, and that's exactly what we will do now. So here we'll just say, uh, I'm making the game mechanics. So when I say game mechanics, I mean like the jumping part. So I'll just say, do this, uh, interface file is equals to load the interface prediction file, and I'll just say that if interface file, oops, interface, come on, you know what, I'm just gonna copy that. If interface file, then I want to do something. Well, specifically what I want to do is I want to set the player y change to a negative 2.5. That's exactly what I want to do. Now, I think I'm going to set it negative 3. And I think if everything is correct, that's it for the actual code. The interface, the model, and the actual game. We have a model, we have the interface, we have the actual game. These are the three files that we actually work with. So now let's actually run this. What I'm gonna do is I'm gonna create two windows, since we also need to run the interface. So I'm just gonna cd to the desktop, oops, cd desktop slash python slash neural network controller, and I'll just go python 3 interface.py and python 3 main.py. Run that and run that. Now we don't have collisions in place, that's something that we will do now. But basically we have the entire game in place, like most of it. Now why isn't the interface.py file running? Wait, so is it like only one thing can run? Alright, let's try running the interface file first, and then let's try running the main file. Maybe that's the issue. I don't know. Alright, it's not even letting me quit. Let's run the interface file first real quick. Come on. Now setup does get a bit tedious over here, you gotta run two files. It does get a bit tedious, but it is pretty cool, right? To control something like this. And for some reason, why is it taking so much of time to load up the interface file? uh, I don't know why it's taking so much of time. It usually is incredibly snappy and quick. It doesn't take this much time just to simply load up a file. Come on, man. The Py game didn't really take that much of time to load up, but for some reason the interface file is just going crazy. Like, it's taking so much of time to simply load up. Come on. There has to be some reason to why it's not loading up. Like, there is no bug. That's something that we do know. There we go. It's loaded. It's loaded. Cool. Yeah. Alright, I think I need to light up my scene a bit more. Uh, Alright. Now let's run the game and see if it works. I really hope so it does. Let's run it. Let's run the game now. And alright, we do have a Pygame window, and the guy is jumping. Let's go. Alright, seems like we have a bug in our code. Uh, like, not the actual main part of the code, but we do have a bug. The guy just yeeted up. So, a height minus 300. You want to set it 2.5. Alright, you know what? I'm going to set it to a 3.2. Maybe this will work. Let's run the interface file and hope that it boots up quickly. Unlike the last time. Come on, please. I don't know why it's taking so much of time. It should have been quick. I think the main reason is because I'm recording, I have a text editor open and stuff like that. Alright, there we go. We got this thing all booted up. Alright, let's see. Let's hope that it works. Uh, Come on. Why isn't the dinosaur falling down? That's something that I just can't understand. Dinosaurs should be falling down, right? You know what? Instead of actually giving like dynamic values that are scalable, I'm just gonna give it like a static value. So, well, when we look at it, a height minus 150, we are talking about 450. Uh, I hope so. Yup. So 300 would be 300. So height minus 300. So if it's okay, I all right. If 300 gets, wait a second. I think I just literally got my mistake. All right, let's see if this works now. All right, let's see if this thing works. Okay, oops, I gotta get rid of that. Okay, why is this dinosaur going up? I just don't get it. Like, he shouldn't be going up. If the player y gets greater than that, well, the player y is always going to be greater than that. You're adding it over here. So, don't get this part. Like, so the player y is always going to be greater than. So, if the player y gets greater than that, if the player y gets lesser than that. Come on. You know what? I think I'm just going to do one thing. I'm going to print out uh, out of bounds player. Alright, let's see. Let's actually, in this case, we don't even need to run the interface. We just need to run the main file. Alright, let's see. Alright, so we are getting player out of bounds. Alright, so there isn't a bug in the code. There's a bug in the logic. So we're setting the player.y change equals to 3.2. We are adding it. Then why isn't that working? Wait, let's just set it to 0. See what happens. Because if the negative 3y changes the thing that's causing an issue, yeah, I think that is the case. If I reduce this to -1, I think even if the player will go out of bounds, it will alright, I think now let's just set that to 3.2. Okay, this is a bug that I didn't think I would encounter, but I am. Oh, come on. Uh, What can I do? You know what? I'm just gonna set the player y equals to that point, cause dot is equals to height minus 300. Let's do that. Alright, let's see this now. Hopefully this should prevent the player from rising indefinitely. There we go. So the player doesn't rise indefinitely now. But there's definitely something wrong with the actual player y change. So you know what I'm gonna do is I'm just gonna print out the player y change over here, see what's wrong with this. So I'm just gonna say print out the player dot y underscore change. Let's run this now and see what's wrong with that. Alright, let's see. -1, -1, -1, -1. Alright, that's weird. So, prediction file. Okay, I get it. I get it. Well, so you look at it. So, I only wanted to check the prediction file once every frame. So what's happening is, uh, so it's like since the thing is a jump, so I'm kind of like messing around with my own thing. So I think what I need to do is I actually need to place this on top of the boundary checking. If like either that or I give up. I can't understand how to fix this. So alright, let's try this out now and hopefully it should work. Hopefully, actually I will need to mess around with one last line to actually see if it's working. Let's see. Alright, so we are having a -1. Alright, -1, -1, -0.2, -1. Okay, so now it's partially working. So what we want to do is if there is an interface file and if the player dot y is less than or equal to the height minus 150, because we don't want the player to jump when he's already in the mid air, because then it will just go then that's just stupid, because how can you jump when you're in the mid air? Alright, so now it's -1. Come on. And the player dot y is less than or equal to height minus 150. What can that be? What, greater than? Oh, yeah, it has to be greater than. Why is that less than? Alright, now let's see. Oh, come on. I really do hope that this works. There we go, it's working. It's working. Yes. We have a player jumping. And that's because I told him to jump. Pretty cool, eh? Uh, so yeah, there we go. So as you can see over here, now we are alternating between 1, -1 and 3.2. That's exactly what we wanted. Now we do want to increase this to about a -3, because otherwise the player will be too slow, which is something that we don't want. There we go. Now we just need to implement collisions. Collisions are pretty easy to implement. So I'm just quickly gonna add that. Uh, let's just do that real quick. Adding collisions. Define is underscore collision. You know what? I'm gonna add collision in a class. So yeah, I'm just gonna add it in the player class. Define is collision. And it will take in self other x other y. So let's say distance is equals to math.sqrt math.pow cell.x minus the other x the whole raised to 2 plus actually I think it was different. Gotta Google it up. What's the formula for the distance between two coordinates? I forgot it. I don't know why. I remembered it till now. I just forgot it right now. Formula for the distance between two coordinates. Okay, so we have a minus and then a plus. So I was correct. Math dot pow self dot y minus other y the whole square if the distance is less than 27 we return a true, otherwise we return false. So now we can just use that and put it in there. We don't need this. So now we can just say collision is equals to is collision player dot x player dot y tree 1 dot x tree 1 dot y. If there is a collision, time dot sleep 0.5 break. So we just import time over here, and I think we are done. uh, that's all we need. So let's just run this file again, interface.py, and we also will run the game. First, let's just get the interface file all loaded up, then we will actually run the game. And I do hope that all of this works, because, well, I will be really happy if it does. So, Python 3 interface.py, there we go, we got it all loaded up. Alright, now let's run the game. Now, as you can see, there is a bit of a kind of a frame issue. Its collision isn't defined. Oops, it's supposed to be layer dot. Alright, so now let me just bring this screen up. Alright, now what's the issue? Come on, man. Its collision takes 3 positional arguments, but 5 are given. Oh yeah, we don't need to give it player x and player y, right? Because we had specified it in the player class. Yeah, stupid errors. There we go. For some reason it's saying jump. It shouldn't be. Come on, come on, give me a normal prediction for some. Come on, how am I supposed to get a normal prediction? Like, I'm trying to fidget with this just so that I can get a normal as my prediction. Something like that. Come on. You gotta give me a prediction as normal. You know what? There we go. Well, we do have this thing all working. It doesn't matter if the accuracy isn't that good. Yeah, there we go. That is the entire thing. Well, why did I open up the cascade? We don't need that.